All right, so welcome back to a video. This video is about constant rate of change. And if you remember yesterday's video and today in class, we talked about rate of change. And we looked at tables kind of like this one, like my lightsaber pointer today. Pretty excited about it. We looked at tables like this one and we talked about kind of like average rate of change. Remember, so we looked at the change that happened between, say, Tuesday and Friday, and we said, okay, well, if this much change happened in 3 days, let's divide by 3, and that's the average change per day. And we said it didn't necessarily have to change by that much every time, but we were going to find the average. Well, today we're going to look at some graphs and tables, mostly graphs, where there is a constant rate of change. Every time the graph changes, it changes by the same amount. And so hopefully this will be a little bit easier to wrap our minds around. But you will see that every time the line goes anywhere, it goes by the same amount every time. Okay, so let's look at this first question. This graph shows how the number of plants Oscar can have in his backyard is related to the number of seed packets he purchases. So as you will notice, this line goes up every time by the same amount. Every time it goes up 2, it goes over 1. Up 2, over 1, up 2, over 1. You will notice that anytime you see a line in any kind of math, it has a constant rate of change. It's always going to go up by the same amount that it goes over every time, okay? Or it's going to go up and over the same amount every time, I should say. So we want to figure out what is the rate of change that's happening here. The key for me is I always want to look at where the line that is graphed goes through an intersection. What do I mean by intersection? Well, I mean, look here at these gray lines. All these gray lines, there's vertical ones and horizontal ones. And where they cross, that dot right there, that's what I'm calling an intersection, okay? So when I look at this black line up here, this one, I want to look at where it goes through intersections, and that will help me figure out how much my line is going up versus how much it's going over, and thus get my rate of change. Okay, so I'm going to say, well, here's an intersection and here's an intersection. So let's figure out how much change happened in between those two intersections. So here, this one is at 5 and it goes up to 7. So that was 2. Remember, this is always the numerator. This axis is always the numerator. So the number of plants is 2 plants over, how much did it change here? It went from 1 seed packet to 2 seed packets. So this is a 1 seed packet line and this is a 2 seed packet line. So I'm going to put here 1 seed, I'm going to abbreviate packet. Okay? So if I have 2 plants over 1 seed packet, that's already a unit rate, right? I don't have to do anything to get it to a unit rate because it's already there. So if I were to write my answer, I would say 2 plants per, I'm going to abbreviate again, packet. Okay, this question is kind of similar in that we see that the line goes up 2 boxes and over 1 box. But one thing I want to point out that you really need to pay attention to as you do constant rate of change problems is that notice these boxes aren't just worth 1 anymore. You see over here on the side 40, 50, 60, each box is worth 10. So if I go up 2 boxes, that's not going up 2, that's actually going up 20. Here are my intersections. Whoops, that's not an intersection. Hold on. That's an intersection. So if I go up 2 boxes, whoop, whoop, I'm going up $20. And then if I go over 1 box from 10 visits to 20 visits, that's 10 visits, not just one visit. Okay, so then when I do my unit rate, well, if I have 20 divided by 10, oh, now we see that it actually is $2 per visit. But you cannot assume that it's 2 just because it goes up 2 and over 1. You always have to look at what we call here your scale. If your boxes are going up by 1s, 5s, 10s, you have to pay attention to that in your graphs. All right, this one's a little different. We're talking about necklaces that Amy owns, and we're looking to see how the number of necklaces she owns is related to the amount of money she spends on additional necklaces. So we're going to look for our intersections again. Here's one. Here's one. Notice this time it only goes up 1 and over 2 boxes. But is that actually what our scale says? It goes from 5 up to level 6. 5 to 6. Okay, that's 1 necklace. So I'm going to write that down. 1 necklace over. We go from $2 to $4. So that is, each box is worth $1. So over $2. Now, your problems on iExcel, they're going to want unit rates. So they're going to say how many necklaces per dollar. They're going to want a 1 down here. So if I have 1 necklace for every $2, that is a half necklace per dollar, right? 1 divided by 2 is a half, or they're going to ask for it in decimals, 5/10 of a necklace per, and I'm abbreviating again, dollar, because I'm running out of room. Okay, so notice it's kind of similar. If you look here, from 5 to 5.5, we go up $1. From 5.5 to 6, we go up another $1. So that makes even more sense with our rate. We could test it that way. That'd be a good way to double check your answers. All right, last problem of the video has a little bit of added level of difficulty. Notice right here we have an intersection, and right there, nope, nope, nope. There's another one. These are a little trickier to see sometimes. But we want to say, okay, how much is this going up and how much is it going over every time? So it goes up 3 boxes, which is what? 40, 50, 60, 70. That's $30. We got to make sure we count correctly. $30, and how much are we going over? We're going from the 10 visit line to the 30 visit line. 10 to 30. Remember we talked about 30 minus 10? Talked about subtracting where we're going from where we're starting. So 10 to 30, that's going to give us 20 visits. Now we need to divide. What is 30 divided by 20? If you do that on your calculator, or, because some people think that's cheating, if you do it using long division, you get 1.5 or 1 5/10. Whoops, not visits per dollar. What am I doing? Dollars, which means, oh, I gotta have the 0 here, per visit. Okay, so please make sure, that's the last problem of the video, so please make sure you write down a question or a tidbit, and if you have multiple questions, that's awesome. I would love to answer all of your questions tomorrow in class and learn some more about constant rate of change. See you tomorrow.